Hello students, in last class we understood about the static electricity and charge, which were the part of the electricity hooked. Now we divided the electricity into two parts, static electricity and current electricity. Static electricity, static electricity we understood about how the charge is created, and where we create the charge in insulators, and charge is not able to move in the insulator. That is why we said it static electricity. A charge on one electron were 1.6 into 10 to the power minus 19 coulomb. And we discussed about the properties of charge, how the properties of charge were founded in 3 experiments we done. Okay, the properties of charge, we understood that like charges repel each other, unlike charges attract each other. Second property, we understood that the like or unlike charge, as they repel or attract, some force is produced, and that force was get by the F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Another one property was, if the number of charges are given to me and someone say that what is the total charge, so I can add them. Q equal to Q1 plus Q2 plus Q3 plus Q4 dot dot Qn. Another one was, last property was quantization of charge. We found a formula Q equal to Ne, where N was the number of electrons. Today, further we discuss about the current electricity. In current electricity, that means something is flowing. Air current, water current, you understand? That same like that, current electricity means something is flowing. What is flowing? Charge. Charge means electrons. Now that means there is some conductor. It is only possible in the conductors, means metals. Metals are the good conductors of the electricity. We know very well, every matter is made up of the atoms. Okay? Every matter is made up of atoms, small particles, atoms. Now, one property we have to understand of the conductor is that the metals have ample amount of free electrons. Means millions of free electrons are available in the metals. Means, for example, these are the free electrons. Free electrons means which are not have any business with the other atoms. No attraction or repulsive forces. Now, so that electrons are free to move in whole of the metal. Now that able to move, and movement of the charge, what the electricity? Charge is produced means electricity, but sir, there is no electricity. Why? Here is electricity, because electron is moving means carrying a charge, moving a charge of minus 1.6 into 10 to the power minus 19 coulomb. But one charge is going in one direction, another charge is going in the other direction. So effective average current, average of these is 0. In this, average current is 0. Now, how can I pass the electricity from this? Electricity, how it is produced? There is no direction. Energy is there, charge is there, moving there, but we need a direction. For example, you want to become an astronaut, you want to become a pilot, you want to become a teacher. Every person, if you realize that you have number of talents in you, number of energy, ample amount of energy you have, but you need one direction. We all need direction. So you have to choose one direction in which all the electrons will flow, right? So for the direction, we need something which will guide these electrons. Then current electricity. These guidance will be given by the battery or the cell. Now, we are giving it one cell. We know very well that battery has one positive terminal and the one is negative terminal. Positive terminal, this part of the conductor is joined with the positive terminal, that means this is positive and this part have the negative. Now, we understood in last class that the like charges repel each other, unlike charge attract each other. Unlike charge attract each other, there is a positive charge, electron have the negative charge, they will attract towards positive terminal. All electrons will attract towards the positive terminal. And we know like charge repel each other, negative terminal, negative electrons, free electrons. So this terminal will repel the electrons towards the positive. That means the direction of the electrons from negative terminal to positive terminal. Right? Now, so now we can conclude that the electric current is the ordered motion of electric charge. Electric current is ordered motion by the cell. We have done a order, one direction we have given to the charges. So electric current is ordered motion of electric charge. Simple definition is there. Another definition we can say that the rate of flow of charge. Under definition we can say the current is the number of charges per unit time. Means the number of charges passing from cross-sectional area per unit time is called the current. We know very well Q equal to NE. Q equal to NE. So I can place the value of NE as Q. So now discuss about the unit. The unit of the current is ampere. Okay, so unit of the current we have discussed. Now, next point is we said you that the direction of the current. The direction of electrons is negative terminal to positive terminal here. Remember this point. Okay, and that means now we take a reference of current. That reference is always taken in the positive side. So if the negative electrons, the electrons are moving from negative terminal to the positive terminal, that means positive has a difference, remember, that means positive charge will flow from opposite direction. That means current is flowing from positive terminal to negative terminal. Understand? Means current is always flow from higher potential to lower potential. We will discuss further about the potential and potential difference. Now we are going to discuss about the potential difference. Let's go. Now I want to discuss the potential. word is potential. May be possible in movies, or your teachers many times said you that you have that type of potential. You have the potential to become an athlete, you have a potential to become an astronaut, anything potential you may have, right? So what is the potential? I want to give a simple statement of the potential: ability to do the work automatically. You are giving a very less effort, but the work is happening. For example, this is an object. At this time, this is not able to move anywhere. Now, I will do some work here. After that, when this object is at height of h, then it is able to move automatically, right? So that is the potential, because potential has, this marker now has the potential work to do automatically, okay, ability to do the work. Now, how the potential will come? The potential, that means how that potential was created. There is a gravitational force on this marker. Gravitational force is in downward direction, right? I am doing the work opposite of the gravitational force. So I am doing what? The work opposite to the gravitational force. So that means potential is coming. So result we got that is potential is ability to do the work automatically. Ability to do the work you can write, okay. Now we can say in other words, how was the potential come? Potential is work done against any force. Then what we say? Potential is work done. Potential is work done against any force. That was the potential. Now in terms of the electricity, there is a charge and there is small charge. Any other charge there? Elementary charge, for example, here is a charge of high magnitude, right? So it has a property of repulsion. It will repel this small charge, okay? This is test charge, this is source charge. So that has repulsion, right? There is point A, another point is B. Understand? And this is the point C. This test charge is at point C, right? So it has tendency to go further towards the infinity, but it will not come back towards the source charge. Now if I do the work to carry this charge towards the point A, then I try to carry this test charge at point A. Now this charge will automatically go through B, then C. Now this charge has ability to do the work automatically. So how it was done? Work done against electric field, electric force, right? So force of, then we have done the work against the force of repulsion. Understand this? So that means I can give one formula for the potential, that is V equal to W upon Q. That means potential is work done per unit charge. Per unit charge. So we can give the definition of the potential or potential difference, that the potential difference is work done to carry a charge from one point to the another point. Right? We can understand the potential difference by a small example. I am taking it fast. Take it. For example, you have some vessel. You have two vessels. One is there, another one is this. You can take the experiment at home. Here, the potential. Here is the height of the water is at this level, but here the water is less. If I join these two parts by one pipe, then what will happen? Here is potential, height is more, then that means potential is more. Here is height is less, that means potential is less. Then the water will go from this vessel to this vessel. Means water. You can understand, you can assume this water as a current. So current is, water is flowing from higher potential to lower potential. Current is flowing from higher potential to lower potential. When it will stop to go, pass from one vessel to another vessel. When will it stop? When the level of water will be same. When the water of the level will be same, the flow of water will be stopped. Understand? So similarly, if the potential of the 2 points will be same, then it will stop. Current will be stop to go anywhere. Now, I am going to discuss about some parts of the electricity. Right? For example, I want to denote the electric wire. Electric wire are denoted by a line like this. Okay? These are the electric wires. If I want to show the cell in the electric circuit, then it will show by a line and with another line. One with the line which is larger, that will be positive, and smaller line will show the negative terminal of the cell. If I continuously join the cells, then it is called the battery. More than one cell is attached together, bind together, then it is called the battery. Now, another essential part we are seeing here, the resistance. We will discuss in this part this resistance. Okay? So resistance means which will resist the current. Here I showed one. This part is called the voltmeter. What is called? Voltmeter. Why? What is the use of the voltmeter? It is used to measure the potential difference. It will potential difference. Volt. Our electric household electric supply come at 220 volts. Right? So now, next part is the ammeter. Ammeter used to measure the current. Okay, we understood now. I equal to Q upon T ampere. So this current is measured by the ammeter. This device is ammeter. Now what is this? This is the key. You can show the key like this or like this. Okay, as you wish. Now next one is, it looks like the resistor, but we can variate this. We can change the value of the resistance. we can variate the value of the resistance, 2 ohm, 3 ohm, 1 ohm. So as we required, we can change this resistance. So this is called the rheostat. Okay, the notation is RH. Means you can say that this is the variable resistor. Okay, in simple language, you can, for the understanding, you can say that type of resistor which can change its value of resistance. Understood? Now, the whole system is an experiment of ohms, and the result of this electric circuit is called the Ohm's law. What he observed that when, for example, if I take the voltage in the x-axis, current in voltage in y-axis, current in x-axis, then he plot a graph of the voltage versus the current from this circuit. Firstly, he took the 0, means here key is open. Then when the voltage was 0, then when the voltage, this voltmeter showing the 0 value, then current is also showing the 0. Next one, if I change the voltage from anywhere, then the current will also change. So as well as I am changing the current, it will also change the voltage. Current will change by the resistance. I'll give the resistance to the current, then current will decrease, and similarly in the proportionally he found that the voltage is also changing. As he increased the current, the voltage will also increase. So he plotted the graph between the voltage and current. He found that current is directly proportional to the voltage. Proportional means one is increasing, one quantity is increasing, another quantity is also increasing. One quantity is decreasing, the another quantity is also decreasing. So he found that by the changing of the resistance, the current is changing, and current is changing means voltage is changing also with respect to the current. That means he found that for changing the proportionality sign, I want to change here equal, and one constant will be there, and this one. So I equal to V upon R, that means R equal to V upon I. He defined the resistance as the ratio of the voltage to the current, and the unit of the resistance, he said, this is ohm. It is what? Ohm. Have you understood? So he found that what we conclude, when the change in resistance, current will also change. Current will change, then voltage will also change. If the resistance is increasing, current will decreasing. Current decrease, then voltage is also decrease. So this plot will come. Understood? If you have any problem, then discuss in the comment section. Okay. Physically, in physical significance, what is physical significance of the resistance? We understand. We know very well. We understood that there is a metal. Free electrons are moving. Millions of free electrons are available. They are free to move. They are moving, but we have to remember that there are atoms also. The matter atoms are also available. So they will resist these electrons, right? So that means, what is resistance? Resistance is to resist, ability to resist the electrons. Electrons ability to resist the electrons means ability to resist the charge. and ability to register the charge means ability to register the current. Okay, so finally we got one statement that the resistance is how much ability some conductor have to register the current. Understand? So now we want to discuss that which are the factors which change the resistance. Resistance, we discuss that if any, for any wire, if the L is the length, A is the cross sectional area, A is the cross sectional area of the conductor, then R resistance is directly proportional to length of the wire. Means as much as the wire is longer, then resistance will be more and more. Means resistance will increase then when the length of the wire is increased. Resistance, next conclusion is, as the thickness of the wire is increased, the resistance is decreased. As well as the thickness of the wire increase, resistance is decrease, as well as the thickness of the wire decrease, resistance is increase. That means opposite is happening. So means R is inversely proportional to the cross sectional area of the wire. If I join this, to R is proportional, resistance is R is proportional to L upon A. To reduce this proportionality sign, I have to add one constant here. So R is equal to rho L upon A. Rho is what? Constant. So that means R is directly proportional to the length of the wire. Okay, R is inversely proportional to the thickness of the wire. Now, what is rho? Rho is called the resistivity of the material. What is this? Resistivity. Resistivity of the given material. They have the specific value for the different materials, different metals. Okay, got it? Now, the unit of the resistance were ohm. Now we will discuss about this rho, right? That is resistivity of material, that is noted by rho. Firstly, this is depends on the resistivity is depends on two factors. One is which type of material that is. Second one is depends on the temperature. Okay. Now, for example, for the silver, the resistivity is different. For copper, resistivity is different. But all copper wires have the same resistivity. Okay. Resistance will change according to the length of wire and the thickness of wire. But if the same material is there, then resistivity will not change. Understood? Now, resistivity is depends on material, conductor, material of the conductor, and secondly it is depends on the temperature. So we understood how the material, how the rho is depends on the material of the conductor. Rho resistivity is different for the different metals. Okay, and temperature, as the temperature is increased, rho resistivity will also increase. If resistivity is increased, then as we know resistivity is directly proportional to the resistance. So as the resistivity will increase, resistance will also increase. So we can take these two results T is directly proportional to the resistance, or I can say resistance is directly proportional to the temperature. One result so we got. What result? As well as the temperature is increasing, resistance will also increase. Resistance of the material is also increase. As well as resistance is increasing, I equal to V upon R. As well as resistance will increase, then current is decrease. That means as the temperature increase, current is decrease. So as the resistance, as the temperature increasing, temperature is increasing, resistance is also increasing. Resistance increase means it will resist more and more resist to the current. Okay, so always as temperature increasing, resistance is increased, temperature with the increasing of temperature, current is decreased. Now we just take the, we know very well that resistance is directly proportional to the temperature. We discuss as the temperature is increasing, resistance is increasing. If I reduce the temperature, what will happen? As the resistance is decreased, temperature is decreasing, resistance is also decreasing, and continuously after decreasing, resistance will be zero for the conductor. So that conductors which have resistance zero at a particular temperature, that conductor now is a superconductor. Okay, so for superconductor, what is the condition? Resistance will be zero. How we can achieve the resistance equal to zero? For the condition for the superconductivity, continuously decreasing the temperature. Now we will understood what will happen if the resistance is joined together. Okay, we can join the resistance each other by two ways: series and another one is parallel. Okay, so now firstly we will understood how we can join the resistance in series. Join one resistance, another resistance will join with the tail of the first resistance. Then you can join another resistance with the tail of another second resistance, and join the first and last terminal with the battery. Okay, with the cell. Let this has the voltage V. This is resistance R1, this is resistance R2, this is resistance R3. This is what combination? Series. Okay. Now in series, if current is going from positive terminal to the negative terminal, we know now, there is no path other than this single path for the resistance. Means current will be same in throughout the circuit. If I current is flowing from the battery, then this I current will be here also in R1, I current will be in R2, and I current will be in I3. The same current is flowing. So we can recognize the circuit if the which is series or parallel by the, if the current is same throughout the circuit, then these components are in series. That means for the series, what is the condition? Current same, current is same, but voltage is different. How? For this, what is V? V1 equal to V is what? V1 equal to IR1. What is V2? Equal to IR2. And for third voltage is V3 is IR3. Right? So now, means for series circuit, current is same throughout the circuit, but voltage are different. Now voltage are different. Now do some calculation here. To V equal to this, V equal to V1 plus V2 plus V3, V equal to V1 plus V2 plus V3, V equal to IR we know. So this is, what is the value of V1? IR1 plus V2 is IR2 plus V3 is IR3. Take I common, R1 plus R2 plus R3. Now I will cancel, R equal to R1 plus R2 plus R3. That means whenever you join the one or more resistances in series, the total resistance you can get by the just add out all the value of the resistances. That means what is the formula for the series? R equal to R1 plus R2 plus R3. Got it? Now for the parallel circuit. For parallel circuit, first resistance, another resistance in parallel with the another one, third one like this. You can join more resistances like this. So this is the resistance R1, this is R2, this is R3, and join this with one cell or the battery, this plus minus. Now current has no path other than this till this point. Okay, but from this node, current has three paths: 1, 2, and 3. So current will divide in three parts: I1, I2, and I3. At this point, I1 will come back from here, I1, this will come I2, this will come I3, and by combination of this, total current will flow. Right? So now, what we discussed in parallel circuits, current is different. Current is different. But voltage is same. Voltage will be same. Here, just check out for the resistance I1. I1 equal to V upon R1. What is I2? I2 equal to V upon R2. Next, I3 equal to V upon R3. Got it? So, current is different, voltage is same in parallel circuits. Same calculation will be here also. If current is same, that means I equal to, current is different, I equal to I1 plus I2 plus I3. Current is different but voltage is same. What is the value? I equal to V upon R equal to V upon R1 plus V upon R2 plus V upon R3. Now we take common form out from here, then 1 upon R1 plus 1 upon R2 plus 1 upon R3. So V upon R, V will cancel out. So 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So whenever the circuit is in parallel, then we can get the total resistance by adding inversely. 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay. Now, for shortcut, if you given that there are only two resistances in parallel, R1 and R2, you can get the direct formula for resistance, that will R1 plus R1 R2 upon R1 plus R2. You can use directly this formula. For example, 1 upon R. 1 upon R equal to what? 1 upon R1 plus 1 upon R2. 1 upon R equal to, take LCM, R1, R2. It will be R1 plus R2. then it will be, if inverse this, so R equal to R1 R2 upon R1 plus R2. So you can use this directly. Get it? For example, I want to give you one example of the combination resistance. For example, in question you have given some like this. This circuit has given you, and you have to find out the total resistance over this. For example, this is 12 volt. This resistance is 1 ohm, this is 1 ohm, this is 2 ohm, this is 2. Right? Now, current I is there. I will come there. In 1 ohm, current is I. Same current is there. Next one. Current will divide I1. Here will I2. I1 plus I2 combined there. Here will again I and this. Now here current is I, here current is I, not in parallel, but I1 I2, that means this is in parallel. Okay, so you can get total out of this R equal to R1 R2, 2 2 ja 4 upon R1 plus R2, 2 2 4. This will 1. Got it? So one result you also got, if the two resistances of the same value combine, we have to combine, then just do the half. 2 ohm, 2 ohm, 1. This is also a result you can absorb. Now the next circuit will 1 ohm, this total is 1 ohm, and it is also given 1 ohm. Now this is the this is for example 12 volt. This is I1. I1 current is flowing whole of the circuit, that means these are in series. So total R is what now? Total R equal to R1 plus R2 plus R3. So that means 1 plus 1 plus 1 equal to 3. I hope you got it. Okay. Now, so these were the series and parallel combinations of the circuits. Okay. Next topic we will discuss heating effect of current. Heating effect of current. You observe many times that your heater, okay, the heater has nichrome wires. Nichrome wire, what will it has the effect? It shows the effect of heating. When the current is so large current is flowing in the wires, then wires will also heat up and burn out. Many times you observe the short circuits, right? So heating effect of current. So heating effect, how the heating in the wires will happen. This will what we discuss now. Heating effect, you have to understand that directly proportional to the resistance of wire. We discussed the resistance. Okay, resistance was to resist the flow of electrons. Who is resisting? Which is resisting? That were atoms, and collisions is happening. The collisions of the electrons at the time of flowing, collision is happening with the other atoms of the matter. Okay, due to these multiple collisions, heating effect is produced. So as well as the resistance is increasing, more and more collisions will happen, and more collisions, due to the more and more collisions, heating effect will happen there. Okay, I hope you understand. Heating effect is directly proportional to the square of the current flowing in the wire. As well as the current is more, that means charge rate of flow of the charge is more. The rate of charge is more means more and more electrons, number of electrons are flowing. As the number of charges increase, number of electron increase, so more and more number of collisions will happen. So the current is also a factor for the heating effect, but it is go in square. Heating effect is also depends on time. How much time the electrons are flowing in the wire, how much time the current is flowing in the wire. So if I join these three results, then output of the result is I equal to H equal to I square R T. I square R T. So these are three things on which the heating effect of current, heating of wire is depends. Okay. Now the next topic, in nichrome wire, in tungsten, you bulbs, LED, you can absorb the heating effect of the current. Nice. So I want to go in the next topic, that is energy. Energy means, you know very well, work done. Work done. If the energy is there, work will happen. And to do the work, energy is required. And you know very well, the unit of energy and work done both has the same unit, that is joule. SI unit this is. Okay. So work done, for calculation of work done, we know very well in the potential we have discussed, potential were the work done per unit charge, Okay, so work done, I can get work done equal to V into Q. Work done, so V equal to Q equal to current into time, V equal to Q equal to IT, so W equal to VIT. W, work done is similar to energy, to equal to VIT. This is the formula for the energy, joule. VIT, joule. Got it? Now I want to get this formula in terms of resistance or other things. Energy equals V equal to, we know IR, and this I T. So it will be I square, I into I square R T. This is also the formula for the energy. Wherever the voltage, current and time is given, you use the formula of energy. Wherever you have given in the question current, resistance and time, then use this formula. Now we can get another formula also. E equal to V into I equal to V upon R into T. From this, what I put? I equal to V upon R. Got it? So it will be energy equal to V square upon R into T. This much joule. Got it? So energy formulas you got. Now I am going to discuss about the power. As we listen, what happened? No. As we listen that the bulb has 100 watt, nichrome wire, or the press has our press has the 1000 watt, right? So power, the unit is watt. What is power? Power we know very well. Work done per unit time is called the power. Okay, so power unit is watt. This will be joule per second, that is also for the watt. Now power equal to W upon T. W is what? Energy upon T. You can put the different values of power. First formula for the power is VIT. Energy is VIT upon T. So T will cancel. So power will equal to, what is the result? Power equal to voltage into current. This much watt. First formula. Second formula for power, next put energy. What is the formula for the energy? Next formula, that is I square RT divided by T. So that will be I square R. This is another formula. This is another formula for the power. What formula? P equal to I square R. Got it? Next formula, power equal to, what is the E? V square upon R into T for power divided by T. So what is the value of P? P equal to V square upon R. This much watt. So this is the, you have to remember this formula, this and out of energy formula were also. I hope you have noted down. Now we will discuss commercial unit of energy. Commercial unit of energy. What was the unit of the energy? SI Joule. What is the unit of power? Watt. What is what? This is the power. The unit of power is watt. Now I am discussing commercial unit of energy. As you take the meter reading in our household circuit, we discuss when we see our meter, energy meter, then we don't say that much joule of energy we have consumed. We always say that this much of unit of energy we have consumed. So I want to tell you about what is 1 unit of energy in terms of the joule. 1 unit. Always remember 1 unit of energy equal to 1 kilowatt hour of energy. Remember, kilowatt hour is the unit of energy and watt is the unit of power and joule is the unit of energy. But kilowatt hour is the unit of energy. Always remember, don't be confused. So how much is the 1 kilowatt of energy? Or we want to discuss how much is the 1 unit of energy. Same thing. So 1 kilowatt hour, kilo means 1000, watt, and I write it joule per second, right? Joule per second is what? Now I can write R. So R means in 1 hour 60 into 60 seconds. Got it? Second will be cancelled. So 6 6 are 36 into 10 to the power 1 2 3 4 5. That much joule. I can write it in scientific notation. That will be 3.6 into 10 to the power 6 joule. This is the value for the 1 unit. Okay. So 1 unit means 3.6 into 10 to the power 6 joule, and this much equal to 1 kilowatt hour. 1 kilowatt hour. Remember this formula also. It will help you to do the numericals. And you have to understand this thing that 1 unit of energy means 3.6 into 10 to the power 6 joule. Understood? So I hope you have understand the chapter of electricity, and for some numericals about the heating factor of current and this rate power energy, we'll discuss some tough numericals in one class. Okay, thank you very much.